Alright, so today we're diving into glucagon, a critical hormone produced by the pancreas that helps raise blood sugar levels during fasting or physical activity. Glucagon plays a vital role in maintaining energy balance and ensuring your body has the fuel it needs. Here's a helpful mnemonic to keep in mind as we go. When the glucose is gone, glucagon. Let's break it all down. The pancreas is a dual function organ located in the upper left abdomen, just behind the stomach. Most of the pancreas is made up of exocrine glands, which secrete digestive enzymes into the small intestine. However, about 1 to 2% of its mass consists of the islets of Langerhans, which are clusters of endocrine cells that secrete hormones. The islets of Langerhans contain 5 main cell types: beta cells, which produce insulin; alpha cells, which produce glucagon; delta cells, which produce somatostatin; gamma cells, which produce pancreatic polypeptide; epsilon cells, which secrete ghrelin. In this video, we're focusing on the alpha cells, which are responsible for producing glucagon. Remember, glucagon steps in to raise blood sugar when levels are low, making it the counterbalance to insulin. Glucagon is a peptide hormone encoded by the GCG gene on chromosome 2. Its production involves several steps. Pre-proglucagon is synthesized and then cleaved to form proglucagon. Proglucagon is further processed to produce mature glucagon, which is stored in granules within alpha cells until it's released into the bloodstream. The primary trigger for glucagon secretion is low blood glucose levels, which can occur during fasting or intense physical activity. When blood sugar drops, alpha cells release glucagon to restore balance. Glucagon secretion is also stimulated by adrenaline during stress or high energy demand, cholecystokinin, a hormone that aids digestion. Other molecules, like somatostatin and insulin, inhibit glucagon secretion when glucose levels are high. When studying this, think of glucagon as the hormone that acts like a refuel light in your car. When energy stores are low, glucagon steps in to refill the tank by breaking down stored energy into usable fuel. Here's a simple mnemonic: when the glucose is gone, glucagon. This reminds you that glucagon is activated during times of low blood sugar, ensuring the body has enough energy to function. Think of it as your body's emergency energy responder. Glucagon binds to the glucagon receptor, a 7-pass transmembrane protein located mainly in the liver and adipose tissue. When glucagon binds, it activates intracellular signaling pathways that promote the breakdown of stored energy molecules. In the liver, glucagon triggers glycogenolysis, the breakdown of glycogen into glucose; gluconeogenesis, the production of glucose from non-carbohydrate sources like lactic acid. This newly created glucose is released into the bloodstream, raising blood sugar levels. Glucagon also promotes lipolysis, breaking down fat into fatty acids, which can be used as an alternative energy source during prolonged fasting. Glucose levels are tightly regulated by the interplay between glucagon and insulin, another pancreatic hormone. During fasting, alpha cells release glucagon to raise blood sugar. After a meal, beta cells release insulin to lower glucose levels and inhibit glucagon secretion. This balance ensures glycemia remains within a healthy range. To remember their roles, think of glucagon as the accelerator, providing fuel when the tank is empty, and insulin as the brake, slowing down glucose release after a meal. Glucagon plays a key role in emergency medicine, particularly for treating hypoglycemia. Glucagon injections are used to quickly raise blood sugar levels in individuals with dangerously low glucose levels, such as those with diabetes. Here's a quick question: which of the following is not an action of glucagon? A. Promoting gluconeogenesis in the liver. B. Stimulating lipolysis in adipose tissue. C. Increasing glycogen synthesis. D. Raising blood glucose levels during fasting. Pause the video to think it over. The correct answer is C. Glucagon does the opposite of increasing glycogen synthesis. It promotes glycogen breakdown into glucose. To recap, glucagon is a hormone produced by the alpha cells of the pancreas. It raises blood glucose levels during fasting by promoting glycogen breakdown and gluconeogenesis, encourages fat breakdown through lipolysis, works in opposition to insulin to maintain blood sugar balance. Remember, when the glucose is gone, glucagon. This mnemonic highlights glucagon's role as the body's emergency energy provider. Want to learn more about glucagon and other essential hormones? Visit kotc.me for practice questions interactive tools, and detailed explanations to master your knowledge. Thanks for watching, and see you next time.